All right. So before we begin for week 3 solving constructor session, uh, there were queries on the discourse that some of the code blocks were not visible when sir recorded the video. So I wanted to go through some of those. Can you specifically point me the ones that you want to look the code for? Hello, am I audible?
Yes, sir. Sir, can you please go through that visualization mainly, like drawing part?
Sure. And apart from that, anything else?
I think that is the main hidden part. We are not very sure about how to do, and the other things I think we could manage.
I see. Okay.
So,
Yes.
those iter tools and fun tools, if you would give a brief.
Okay, sure. So in the last session, we talked about iter tools as well as reduce function. I'll give a demo of both of them.
Hello, sir. It would be really helpful if you go through all the topics rather than going through the activity questions. And if anyone has problem, they will ask you the question. I think that would be helpful.
So Abhishek, today we are not going to go through the activity questions or practice questions. Today's session is actually solve with instructor session for week 3.
Okay, sir. Then so we are going to discuss week 3 here, right?
Yes.
Okay, sir. Absolutely.
So I think this is the collab which sir explains the visualization part for region Lasso both. So is this visible?
Yes, sir.
Should I start from the top or should I just go through the visualization part?
Top, sir. Sure. From start.
Okay. So this collab is specifically for region Lasso visualization and having better understanding of it, how they are represented geometrically. Some useful imports. Same here. So this code you must be already be familiar with, which is just getting the polynomial transformation of features. Yeah, stop me at any point of time when if you want to focus further.
Sir, so what is the
Yes.
use of logging which was mentioned in the type of code?
Where?
Logging in the linear regression about if logging and
Not able to see any logging. This one.
yes, sir.
Right. So yeah, so logging, if you want to have more verbose internal details of how the function worked and what were the steps. If any place you want to put printing of any kind of messages, intermediate results, you can use this flag logging. If it is true, then you are actually printing more details than normal. Otherwise, if the logging is false, then by default it is false. Then it is not going to print the intermediate results. It is just going to return the answer. Make sense?
So can you explain a little bit if you go a little bit up?
Okay.
Yeah, X comma none is there, right? That we are assigning in polynomial transformation.
It's common. Yes.
Yeah, X to 10.
So, yeah. So what? This is another way to increase the dimension of data. So if X has only one feature, right? So it will have only one dimension, possibly row type array. Sorry, a single dimension array, and all it has only one feature. In that case, what we want to do is we want to let's say there are I should say 100 samples, only one feature. Right, so the data we might get is might possibly be of only one dimension, 100. That's it, 100 comma nothing in nullity. So what we want to do is we want to make sure it is 100 by 1. It has 2 dimensions. So for that we use this kind of syntax. This is another way to reshape your array. You could have used a reshape or expand dim function also.
Sir,
Yes.
yeah, I mean, are you adding that dummy feature in this way?
No, not dummy feature. Give me one more.
We are reshaping 100 comma something to 100 comma 1 or so that we can
exactly. So
But how
I can show you an example.
Yes,
how
sir.
none is doing that part.
How none is going to do that part? That's interesting question. Actually, there are a few more methods to do so. One of them could be using numpy.new access as well. Okay, so let me give an example. Okay, Venu has asked a question, why do we need n by 1 rather than just n itself? Okay, that's a very interesting question. An answer is, so Venu, before I move forward and answer this one, why do we do this? See, we are going to take transpose of the array. The reason for that is, in later for loop, what we are doing is we are referring to features. Where did it go? This one. Get combinations xt transpose, which is our transpose data, and degree. Okay, and if you look at this code, get combination, it is simplifying things. It's a bit more complex than that. Okay, maybe I should use a pen and paper how it's working. Okay, so first of all, if I print the shape of x, now it is x just 100. If I transpose this matrix x dot t and then print its shape, I'm not going to get anything different, any different result. I'm going to get the same result. And this, to make sure that this transpose operation is successful, I have to reshape this array. Now, question comes to, why do I need to reshape my transpose basically my data matrix? So, I hope my screen is visible.
Yes.
Okay. So imagine that you have a data set of something like only two features. There is 1, 2, 3, 4, 5, 6. If I represent it in a numpy array, it will look like 1, 4, then 2, 5, and 3, 6. Something like this, right? And if I transpose it, the matrix will look like 1, 2, 3, 4, 5, 6. Something like this, right? This is my 3 by 2 array, and this is my 2 by 3 array. Okay. Now, when I'm generating combinations, when I'm using iter tools, generate combinations with replacement. Let's say if I want to create a degree 2 polynomial. So for a minute, just consider 1 and 4. 1, 4. Okay. So what will happen is maybe a few more numbers, not 1, just 4. 1, 3, 5. Okay. So I will get combinations like 1, 3. So how will it index it? 0, 1, 2. 0, 1. Next will be 1 and 5, which is 0, 5, 0, 2. Next will be 3, 5. 1, 3. 1, 2. Is this clear as of now? Hello?
Yes, sir.
Okay. Now
so even
yes.
we have combination 1, 1, 3, 3, 5, 5 also, right? Because we are using combination with replacement, right?
Combinations with replacements. Yes, sure. So, but right now I want to focus on the indexing part. So
Sure.
this is how the indexing will work. Okay. Now, imagine you are working with this 2D array, right? So I want to get the first feature, which is this one, which is this feature, right? And second feature is this one. But how would I index these? That's the big question, right? I want this is my first feature, and this is my second feature of my original data. How would I get it? If I try to get it using this, it will be a bit difficult, not impossible, but difficult. So what we do is we transpose it, and if we call get replacement on get combinations with replacement on this structure, how the indexing will happen? So the first feature will be indexed by 0, right? Because this is the first row. The second feature will be indexed by 1, which is the second row, right? And this is how we can get combinations. And if you look at the code, which will do that in a minute, then once we get these combinations, we just multiply those using the reduce function, right? And therefore we need to take the transpose. If we don't take the transpose, getting the features easily by just one index is not possible.
So this reduce function is for multiplication.
Right. I'll show you example of that as well. So so far, is it clear why do we need transpose?
Sir, I have a doubt, sir.
Sure.
Sir, we are doing the feature transformation on the feature matrix, right?
Feature transformation, feature matrix, yes.
Yes, and if I have 1, 4, then I need 1, 1, 4, 1, and 16, and 4. Like
1, 4, 16, and 4. Yes.
Yes, like that. So if I am doing a combination on 1, 2, 3, that will increase the number of rows, no, sir? I mean,
Number of columns.
Number of columns in the transpose
Yes.
matrix.
Yes. In transpose matrix, it will first increase the number of rows, and what we'll do is we'll again transpose our new matrix so that we get the polynomially transformed data properly. Columns are features. Some yes, right now.
So in this transpose, what you're given 1, 2, 3, and 4, 5, 6,
Mhm.
I'll get if I do the polynomial the transform,
Mhm.
not the polynomial transform. If I do the combination and they reduce, so I'll
Yes.
get 1, 1, 2, 3, and 4 and 9.
Sorry, sorry, I didn't understand that part.
So if I do a 2 degree on this,
Uh-huh.
so if I do a 2 degree on this, what will I get?
Okay, okay, sure. So let me draw that example. Let's say degrees 2 is equal to 2. Okay, so this is my zeroth index feature. This is my first index feature. What will happen is 0 multiplied by 0. Another will be 0 multiplied by 1. Another will be 1 multiplied by 1. Right?
Right.
Okay. So this will become row 1. So I'm not going to use commas for quickness of writing. 1, 2, 3 multiplied by 1, 2, 3. Again, remember this is element wise multiplication. Well, anyway, since it's rows, it's fine. And next is 0, 1, 2, 3. Yeah, multiplied by 4, 5, 6. And here I'll get 4 by 4, 5, 6 multiplied by 4, 5, 6. Right.
Right.
So what will be the answer? This will be a row vector 1, 4, 9. This will be another 4 row vector 4, 10, 18. This will be another row vector 16, 25, 36. Right?
Right.
So after using reduce function, so reduce function does this multiplication.
Right.
There could be there could be third degree polynomials as well. I can show the example of that as well. So once these rows we have received, okay, this is each of these rows represent one feature, right? One new feature.
Right.
Do you agree? So what we
Right.
do is we concatenate them just like we add rows to any new matrix. So this will become like a new matrix like 1, 4, 9, 4, 10, 18, 16, 25, 36, like this. Again,
Okay.
this is not the perfect answer we are looking for because the rows are the features. What we want are the columns as features. So we are going to just transpose it. So this will become 1, 4, 9, 4, 10, 18, 16, 25. Oops, this looks okay. Something.
Okay.
That-
So you get a
Does it
3 by
make
3 matrix.
sense? Only for this second degree transformation for this matrix, yes.
Okay.
Right, there are two features, and if we are doing just second degree transformation, again, this is a step in getting the actual polynomial transformation matrix, because when we are doing the second degree polynomial transformation, we also add the lower degrees, which is degree equal to 1. Let's say if
Right.
this were 4, then we have to do this exercise for 1, 2, 3 as well as 4.
4.
And all the
Okay.
rows we had received like this, we stacked them together and ultimately transform the matrix before return. Make
Okay.
sense?
Yes, sir.
Okay. So now let's go to our polar. So somebody asked why do we use null? So it's another way to increase the dimension of data. This is right now. See, if I do the transpose, I'm still getting 100, 0. 100 by nothing, because in NumPy, if you transpose a single dimensional array, you're not going to get change anything. So what we need to do is we need to reshape. So this represent now see, this represents a single feature. Imagine this is a single feature and it has proper shape 100 by 1. Now if I transpose it, what am I going to get? 1 by 100. And now if I print it, it properly gives me a row. Okay. Now imagine instead of one feature, there are two. Okay, now the transform, this is how it looks like. And if I transpose it, it properly gives me 2 rows, each row corresponding to one feature. Now, this is the one. See, this is the point where when I was, this is the line which belongs to, if you want to get up to degree 4 transformation, polynomial degree 4 transformation, we have to start from 1 as well as go from 1, 2, 3 and up to 4. Does it make sense?
Yes, sir.
Okay. And see this one. For items in get combination. So get combination functions, just where it is, where is it? Yes, this function, it is going to just return you, for example, x is our 2 degree, not 2 degree, 2 feature matrix as I drew on the MS Paint, you saw a minute ago, degrees 2. So every time we call this function, it is going to give me 2 elements, 2 rows from that matrix, which is our transform matrix. Then what we will do, we just append this new feature that we want to compute using this one, append features, and I think where is it being reduced? I see. There it is being reduced. This one. So the
So
item,
this it's
yes.
already lambda is already performing the reduce. So what is this dot reduce for?
No, lambda function is not performing the reduce operation. Lambda function is telling reduce API how to perform this reduce function. So how to aggregate the results. Okay, so let me give one more example. So imagine we have a simple x is equal to, not x, a is equal to numpty dot a range 100, not even this is large number, maybe 1 comma 11. So I have 10 numbers starting from 1 ending to 10. Right. Now what I want to do is I want to multiply every element in this array. Okay. Now there are 2 ways to do it. One way is to just write your for loop and do that. Another method is by using reduce function. I hope reduce is directly callable, or should I have to export something? Okay, I have to. So let's say again, as I mentioned, I want to multiply and all the elements inside this array A and get the result. So x comma y, x star y comma A. And I'll tell you how why does it work. See, this is the multiplication. So basically, this is factorial time. I can reduce its length also. So let's say 6. I'm getting 1. So what it does is, see, this is the function that is reduce function is going to use when working with the elements of A. So first thing that will do is, it will take, since we are defining a function x comma y, which takes two arguments and returns their product. That's all. So what the reduce function will do is, it will take the first two elements of the array, which is a, multiply them. The output will be 2. Then whatever the output will be 2, which is in our case 2, multiply it with 3. Now it will become 6, right? Now the array will become 6, 4, 5.
Got it, sir.
Again, this function will apply. 6 and 4 will be multiplied, and it will give you answer 24. The array becomes 24, 5. And now again it multiplies and gives the result 120.
Got
Does it
it,
make
sir.
sense?
Yes, sir. Got it, sir. Thank you.
So this is how reduce works. Of course, it does this internally, so it does not create another array, but you can imagine how does it work. Now, coming back to our code, see this one. So get combinations here. Compute new features items. So compute new features. This is the one. So this does the multiplication as I had shown you in the MS Paint a minute ago. It does the multiplication. It creates a new feature in a row format. And what do? We append that new feature into our this new the final matrix, which is used to collect all the new features. So features dot append, we are going to append a new feature to this. Once all of these features appending is done, see, look at the end. What is the output it is returning? So in features matrix, all the rows correspond to features, either the already existing one or the new powers, right? We are converting that to a numpy array and returning its transpose. Okay, is that clear?
So one question in get combination. Hello.
Sure, tell me.
So like get combination, when we use x underscore transpose, so in that we make a combination on rows wise, right? Or it's on element. I thought like it's element wise, but you are telling it's row wise. Okay, got it. Thanks for confirmation.
One general question, sir.
Yes.
Normal languages like Java, C++, we have the debug option where we can put the breakpoint and look at the values. Is there any similar tool available here in Python? Other than like logging, means I think currently we are just using the logging, but it will be really helpful if we can put the breakpoints and see the values of different variables.
See, breakpoints.
Though that depends on debugger, what debugger you are using. You can enable in debugger. Like in Colab, I'm not sure, but in ID, Eclipse, and all, you can get it.
Okay, it will allow us to like debug Python.
Yeah, in Spider also it's available if you can use.
Okay, thank you.
Okay.
But in case of function, you won't be able to see that. Spider doesn't allow the function to debug. You need to print in between to see the variable's value.
So you cannot step in and step out in Spider, is it?
No, inside a function, I cannot. There is a variable space in Spider, so you can read from there. But when we are writing a function, the variable doesn't get generated. You need to print instead of going to that variable space.
Okay. I'm not familiar with the Spider. Okay. So whenever in doubt, if you want to see print statements is definitely can help you. But putting so many print statements. So there is a debugger called PDB.
Sir?
So let's move forward.
Sir, could you please explain the logging part, sir?
Yes. So say logging is this parameter login is allowing us to see the intermediate results also if we want to debug it for any other purpose. So let's say I'm going to copy this one and paste it over here. Using this, I have both libraries as well. All right. Now I already have a temporary which is two features methods. Here it is. Now what I want to do is I want to do its polynomial transform. Okay, so let's do it. Polynomial transform. Okay, for better understanding the output, I'm going to reduce the size of this array. Let's say make it 8 elements, and I'm going to make it 4 by 2. Okay, and I'm going to call polynomial transform next degree, which is 2, and I want to keep. So first, let's try with logging. Logging is equal to false. This is going to give me the transformation. Okay, this is my answer. But now, if I set the logging is equal to true, I'm going to see the intermediate results also. See, this was the input. There were some other print statements also there inside it. All of these are being printed. So these are just debugging steps basically. If you want to intermediately see what is happening in this function, you can turn the logging on. Make sense?
Sir, can you repeat? Actually, can you repeat what you said?
Pardon me?
Hello?
Yes, yes.
Can you repeat, sir? Actually, there is bad voice coming, sir. No? So what
There's
sir,
some-
can you repeat?
There's some background noise coming, sir.
Oh, is it? Is it better now?
Yes, sir. Oh.
Okay.
Background
So,
noise of a bird.
okay. Actually, give me 1 minute. Okay, so this logging feature allows you to see inside the function when it is executes. See this one. So what are we printing? When the logging is true, if the logging is true, it is printing the input. And you can see it over here, which is right. Then what is the next thing that we are printing if logging is true? This one, right? So it is printing the items also.
Sound is still coming.
Pardon me?
Sound is coming, some noise or something.
Sorry, I'm not able to hear you clearly. Is there a network issue?
You can type your question.
See, what it is printing is what is the list of features that we are going to multiply, and then this is printing the combination by multiplying those features. What we are going to get. This is what we are seeing over here. See this one. The first two lines are maybe not that clearly explicitly explain this idea. Look at this line. Okay, so there are these two features that we are going to multiply for second degree polynomial transformation. and the answer we are getting is this one. Similarly, when we multiply these two features, we select these two features to be multiplied, we are going to get this output. Exactly like we talked a few minutes ago when we saw an example by hand.
Yes, sir, like 0, 0,
Now,
0, and 1, 1.
Exactly. This is the answer. Yes. So you can see multiple features. We are going to get a new feature, but in a row format, right? And then what do? We multiply. We stack them together. Maybe I can write one more print statement to see how feature matrix is looking. Right. Here you can see the feature matrix is looking like this. Every row in this matrix represent a transform feature, either degree 1 or degree 2. And at the end, what do? We take them together, convert into a NumPy array, and take the transformation. Now you can see that the first array, first column is 1, 1, 1, which is the output over here. The second column belongs to second row in this features matrix, which is 0, 2, 4, 6. And you can see here 0, 2, 4, 6. Similarly, third row is 1, 3, 5, 7, and the third row here is also third column is 1, 3, 5, 7. Does it make sense?
So
Yes,
the next
sir.
few columns are x square, y square, and the xy term, is it?
Exactly. Yes.
Okay. Sir, I just joined. I didn't join before. I just wanted to ask you, in that code, there is a logging which is true. What does that do basically?
Right. So I was explaining exactly that. So see this one. I have created a toy feature matrix 4x2 size, and I've set the logging equal to true. I'm doing second degree polynomial transformation. So whenever logging by setting logging equal to true, I want to see the intermediate results also, not just the answer. And for that reason, I'm setting logging equal to true. So whenever you can see if logging, if this is true, it is going to print the input matrix.
Okay. Yeah.
Over here, if logging is equal to true, it is going to print the features that are going to be multiplied, and the new feature which is computed from those features. And if logging equal to true, the feature matrix and its transpose also.
Okay, sir. Yeah. So this is
Does it
another.
make sense?
Yeah, it does, sir. So this is another line of code which you put. So whenever logging is equal to true, you get that printed out.
Yes.
Okay, sir. Yeah. Thank you.
There it is. Now I think it should be a bit more clearer. So this is your feature matrix without transformation. Every row is a feature, and when you do the transformation, it looks like this.
Yes, sir. Thank you.
Okay.
Sir,
Yes.
what is the purpose of as array? I mean, why are we using as array instead of just array?
I think both will work. Don't have to worry about.
Okay.
And one question that I saw in the chat box is, please explain the get combination function. So this is that function over here. Okay. So let me explain this this function with an example. So we had an array A, right? It has 5 elements. So I'm going to execute this one. This is statement over function over array A, and let's say degree is 2. Let's see what it results. I see. It returns an iterable object. For I in, let's do this. There it is. So my original array, which is A, it has 5 elements. There it is, 2, 3, 4, 5. So please remember that I'm going to use. I have said, give me combinations of 2 elements of this array. Every time you give it, just put those elements back for replacement. So you can see it is returning me the index. It is returning me the index, not indexes, sorry, the elements itself. So 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 2, 2, and so on. Is it understandable? Hello?
Yes, sir. So your voice is breaking in between sometimes.
Okay, give me one moment. Okay, how's now?
Still breaking.
Still it is breaking. Hello?
It's breaking.
Oh, I'm really sorry.
Now it's
I
fine.
think my network connection is having some issues.
Yeah. Now it's fine.
Now it's fine.
Okay. Okay, great. So I was going over this combinations with replacement function. So it's a utility function provided to you inside data tools. Please notice this. A has 5 elements, 1, 2, 3, 4, 5. And I'm going to get the combinations of 2 elements at a time from this array A. It is not going to repeat the combinations. It is going to go through all possible combinations. Now you can see 1, 1, 1, 2 up to 5, 5. All combinations are there. Is it understandable?
Sir, what is the meaning of with replacement?
Good point. So with replacement, let's say 1, 2, 3, 4, 5. If I replace, whenever I take an item, it can still be pulled out of a bag. So imagine I have a bag of 5 elements, 1, 2, 3, 4, 5, and I want to create combinations of 2, right? So one thing that I can do is I pull out one, I do not note it down, and I don't put it back. That is without replacement.
Okay,
if I put
sir.
it back, it can be pulled out again.
Okay, got it, sir. Means, sir, by default, if I'm not writing with replacement, so it won't taking the default value with replacement.
Yes. So we want replacements, and that's why we. Maybe another example we can do.
No, sir. My question is, if we don't write, I simply write iter tools dot combinations, and I don't write with replacement. Then what will happen?
As I mentioned, right? It is not going to. You want to talk about this one, right? Let's do it. Let's call this one. See, this is what it does. It is not going to give you the repetitions. So once first element is 1, the second element cannot be 1.
Sir, even if we take the example of bag and ball example, so if only 5 balls are there, so how I can create the combination of 1 and 1? If I think in terms of the probability or permutation combination.
Okay. See, there are 5 balls inside a bag, and you want to figure out if you want to allow repetition or not. Right?
No, if we take same example, I have 5 balls in a one bag, and I want to get the combinations.
I think you need to put 2 bags, like with 5 balls each, and then you decide the combination.
No, you are picking
Right.
it 2 times. Then only you can do it.
You
Here
can
you are
have
picking,
two
you
bags.
can pick 2 times. Then you
Even
can,
I took one ball and I put it back.
yeah, you keep it back, put it back, and again you can pull out that same ball, right?
In that case, with replacement, without replacement will work.
Yes. So that will be with replacement. You are putting the same ball back into that bag, and you are again picking the same ball. Then 1, 1 that way.
Yes.
Right.
Okay. So, miss, okay, I miss.
Is it clear now?
Yes, sir.
Okay.
Yeah.
So we want with replacement because we want to choose, if need be, we want to choose same feature multiple times. For example, if we are doing third degree polynomial transformation and we have 2 features, a comma b, then what we want to do is the features will become a raised power 3, a square b, then a b square, and then b cube. All 3 of them we want, right? So you can see that the last feature b being used 3 times. In the second last feature, b is using twice. In third last feature, a is being used twice, and the first feature a is being used in 3 times. So I can even see, you can even see this one. A is equal to, let's say, numpy dot array 1 comma, let's say just 3 elements. Okay, and see what it gives you. Okay, right now I'm using combinations, not combinations with replacement. There it is. Oh, degrees 2. I have to set it to 3. And now 1, 1, 1, 1, 1, 2 up to 3, 3, 3. We need this kind of feature. We need replacement. Otherwise, our answers will we will not compute the polynomial transformation correctly. Does that make sense? Okay.
Is there any formula to calculate the number of combinations like this?
I'm pretty sure there is an analytical formula for that.
I was looking for that
because
it is 2 to the power number of features.
For which degree?
No, means a number of degree means suppose there are 2 A and B and 3 features, so 2 to the power 3. So there will be 8 combinations.
2 features and third degree.
Okay. But I do not remember exactly, but there is some formula in the lecture, video lecture.
Okay.
Yes, I totally agree. There is an analytical formula for that because it is basic. See, this one is, I think, NC3. Yes or no?
Yes, sir.
Yes, sir.
Sorry, degree is 3, right? So we want combinations of 3. Okay, I am also forgetting that formula.
No problem. I look at the video.
Okay. So let's go back to our code. So any further questions in this code? How we are creating polynomial transformation? All right, let's move forward. So this kind of function that we have already gone through, right? Scatter plots, plain simple plots, different color, C stands for color, green and red, what kind of label we want to assign. We have gone through this, so I'm just skipping it. This is the code for implementing linear regression from scratch. We initialize to constant t0 and t1, which is going to be used for learning rate schedule. How do we predict? We have the x, the feature matrix, or the samples on which we want to make the prediction, and we have the learned parameter vector.
Can you explain the overall use of self in this particular linear regression class?
Right. So, can you tell me what is the self keyword? So, self is a keyword. So, whenever you use, whenever you define a class, if you want to mention that, so by default, whenever we call a function on any object, right? So, in that function, basically, we are passing that all the properties of that function. So, hence that function itself. So, the first argument for any functions which is inside this class will be self, SELF. That's a keyword. So it is like this in Java, if you remember. So this .w is in Java is equivalent to self.w. So the objects, whenever we call the predict function, it is going to take the parameter vector from the object itself and multiply it with the x, which is the samples which are being passed over. Make sense?
Yes, sir.
Okay. So loss function, if you remember, this is how we practiced it in one of the assignments. This is your RMSE. Yes. Yes.
In AX, we are doing that AX colon NP dot array or something.
Right.
Yeah, so that is converting it into an array, right?
No, it is specifying that the arguments, the parameters passed into this function RMSE. There will be two parameters, x and y, and both of them will have type numpy dot nd array.
Okay, so if we enter any other data type, it will not accept, right?
Yes. Yes.
Okay.
All right. So this is RMSE. I'm pretty sure that we know how to compute it. This is the fit function. And now you can see this function is using analytical method, the normal equation method to compute the weight vector. So first we initialize W with a set of zeros. Then we compute the identity matrix. It's just initialize it because we need to multiply it over here. And instead of using our method of linear taking the inverse, pseudo inverse, or like that, we can use linear algebra modules solve method also. Okay, again, it is still going to give you the same answer that we have computed using normal equation method.
Sir, is this linear regression? This linear algebra dot solve.
Yes, it is going to solve the linear regression equation for weight vector.
Okay, sir. And if we want to do the inverse, is there any function like inverse or NP dot?
Of course, P inverse, there are.
Okay, sir.
So you're saying this will give the same answer as P inverse? I can't hear you.
Yes, absolutely. This is going to give you the same answer.
Okay.
So linear algebra, this module inside NumPy library has functions APIs related to linear algebra only specifically, and that's why a separate module for that, numpy.linearalgebra.solve. Okay, moving forward. So this one is analytical method, the normal equation method, and now this one is now the other method is using gradient descent. So you can see that this function computes the gradient, which will be used in the next function, which is update weights. See, this learning schedule, you don't have to worry about it. All you want to make sure is it is decreasing with time, so that our learning step is smaller as we get closer to the optima. This function, GD function, performs the gradient descent as you had seen in the lectures. We initialize W, the weight vector, with zeros. You could have initialized with anything else also, completely fine. Then we want to keep track of the errors at every step and the W's at every step. The number of epochs we want to run. See, this function is being used for computing the gradient. Then we use this function update weights. We pass it the learning rate as well as gradient. And of course, if you look at the update weights function, it does nothing. It just does this. Whatever the previous value was minus the learning rate multiplied by gradient, which is a standard formula for computing or updating weight vectors. Yeah, here we are. It appends loss also. So it's only for these things will come handy for creating visualization. And yeah, keeping track whether your gradient descent algorithm is actually learning or not. Everything is going fine or not. If you want to look at the learning curves as well. Now this one is for MBGD, mini batch gradient descent. See this one, the number of epochs, everything is okay, but instead of just updating the weight vector right away, we are taking small batches of the weight vector, not weight vector, small batches of our input data, compute the gradient with the help of only that batch and updating our weight vector. So this entire process, going over all the batches once constitutes one epoch, and the number of epochs is still same as that in gradient descent. Similarly, we have SGD. All the initializations are as we discussed earlier. Initial weight vector. We want to keep track of all weight vectors after every iteration, every epoch. Then the error after every epoch. Okay, so this one is not after every epoch, every update we are doing this. See this. And how many in every epoch, how many number of times we are going to update our weight vector, which is going to be equal to number of samples. And number of samples you can get is number of rows inside your feature matrix, which is x dot shape 0. Okay.
Okay, sir.
All right. So this was all the code for linear regression class. Let's go to the visualization part of that everybody has questions about for the region Lasso visualizations.
Sir, is this the same collab which Sir has used during the lectures?
I think so.
Yeah, okay.
Sir, if I could just interrupt and ask
yes.
one. Are we
Sure.
going to discuss the week 4's collab as well? Because what happened is, while I was going through the lectures, the code for the least square classification was abruptly like the video was abruptly end and the code was not shown. So is that going to be discussed today or?
Okay, so there will be another session for week 4.
Okay, so that won't be discussed
Activity
today.
questions plus practice questions. Okay, so there will be separate session for week 4, and
Okay,
it will happen on Thursday.
Okay, sir. Okay, fine.
Yeah, since paradox happened last
Yeah.
week, so we had to reschedule some of the sessions.
Yes, yes. Only the
Yeah.
concern was because the video was ended abruptly and the code was not shown. So I was a bit.
Sure. I'll make sure that it is shown properly.
Yes, sir. Thank you.
So will we discuss practice assignments today?
For week 4?
For week 3.
Right. So did we get a chance to go through them last time?
No, sir.
Okay, we'll do it. We'll do it today.
Okay. Thank you, sir.
So yeah. So okay. So this is the code for visualizing Lasso and ridge regression. Yes. Do you want me to go through these as well? Or you
Yes,
just
sir.
want to take...
These codes were not shown in the lecture. So.
Right. I understand that. So yes. So do you want me to explain them what's happening, or you just want to look at them, learn them, and then come back?
I would like to learn them and then come back because can't ask any questions.
Sounds
But I
good.
didn't know how to
Yeah.
create them.
Yes. Sure. Sounds good.
Hello, sir.
Yes.
Sir, in Coursera, whenever do I course, there is a separate section in which the instructor provide every code in one go, means 2 to 3 minutes. I will also recommend suggest you to provide a video of that thing in one go. There are all codes of that very big will be available there, in one go, in one video, about 2 to 3 minutes. That will take just.
I see.
In Coursera,
Okay.
in Coursera, they do, sir.
Yes,
they provide every code in one go. That will be helpful, sir. Whenever we are stuck during watching lecture, we will watch that video and do very well.
Okay. I completely understand what you're saying. So I think from up to week 3, there are some videos in which sir recorded with code blocks folded. From week 4 onwards, I think all the codes are visible, and even if they are not visible, you can just write a comment in the discourse. I'll make sure that those code blocks will be shown in SWI session at least. Okay, does that work?
Yeah. Okay, sir.
Okay.
So in Lasso and ridge regression, when we have the circle as well as the parabola meeting each other, that is exactly the point where the loss function, the minimum loss function lies, right?
Yes.
And what about in the other one where the polytop meets the parabola, sir? I had a confusion on. I mean, when sir was talking about, he was there are 2 points there where it intersects. So where does that loss function lie here?
I see your point. So you're saying that this red ellipse is touching this polytope twice.
Yeah.
Is that what you're saying?
I agree that there is another polytope which goes through the tip as well. So is that basically the loss function?
Right. That will correspond to the answer returned by this Lasso regression. Yes.
Okay.
So see, these contours are plotted rather granular level, so to help visualization. But these ellipses are actually, if you plot them like a continuous surface, this will be a 3D surface, right?
Yeah.
And this polytope, if you also plot this in a 3D, this will be a smooth 3D surface, completely connected, right?
Yeah. Would it be 3D or 2D, sir? It would be just a plane, right? The contours?
The polytopes?
Yeah, or both of them basically.
No, both of them will be 3D surfaces.
Okay. Okay.
So, if you want to imagine this polytope in a 3D surface, imagine this, that you have I'm not able to get in a proper some kind of example. It has 4 sides, right? So it is like at the bottom, it is a very small square, and as we increase the height from bottom to the top, its square is increasing smoothly.
Okay, so it's basically conical, kind of a square cone, basically.
Yes, exactly.
Okay.
It's a cone
Okay.
with sides as cone, right?
Yeah.
As a polytope.
Okay. Okay, got it, sir. Yeah.
And similarly, yes.
So in this lasso, one question.
Yes.
Sir had mentioned that it will. Why most of the weights are 0? He mentioned about something about the intersection of the ellipse with the polytope.
Okay.
That part I couldn't understand because he said it'll only intersect at the edges. So could you just explain that? I mean, in a lasso, most of the weights become 0, the irrelevant ones, and only the important ones are.
Yes, sir. I also have same doubt, and sir, I have another doubt that might be very silly. That the dots are going straight up to the but at the end they turn
right
abruptly, and in the that ridge regression they come in the straight line, then they take a smooth turn. So why they are turning?
See, we are every point at every point. What we are doing, we are looking at the gradient where it should move towards, right?
Okay.
That's why. So when you are at the edge of two surfaces, two planes of the surface, then you will see that there is a straight ridge, and from that point onwards, you just follow towards the origin. Does it make sense?
Means from the point where we take turn means we have reached at the top.
Not the top. We have reached intersection of two sides of this surface.
No, sir. Where we have put the cursor now? So
okay. So I think it should. So the index, the coordinates of that point where we are taking turn is 0 and -1 to point, -1.2 something. Do you agree?
Yes.
Right. So this is the point where we are hitting an edge of this surface. Okay, so imagine it's a canal, right? It's a canal or a funnel type of shape, and the surface of the edge of it, it will just move in that direction, the canal side. It is like you fold a paper, right? So if you make just one fold in the paper, there are two surfaces which are intersecting at an edge, right?
Yes, sir.
Right. So if you tilt that folded paper and put a small ball, it will just move along the edge, right, between those two surfaces. So that's what is happening over here.
Okay. And sir, in the case of the ridge, that is, can you also say that figure?
Sure. So in the case of ridge,
yes,
right.
It is.
Yes. Here it is.
Yes, sir. It is gradually means shifting. Means that is not sharp turn.
Absolutely. The reason for that is the black lines, which represent the penalty term, right? It's it's very smooth. It doesn't have edges. It's a smooth 3D surface, like a bowl.
Okay.
That's why it is not taking sharp turns.
Okay, sir. Okay. Thank you, sir.
Okay.
So
yes.
So can you please show the code of both these lasso and ridge regression? Slightly scroll over them so that we can take screenshots, because this was completely hidden in the lecture.
Absolutely fine, man. I'll do that. So should I start from here?
No, sir, from
Sir,
the code part.
sir, can you explain the code part as well?
Right. So actually, one of the audience members told me that they would like to go through it once, learn it. If they have any doubts, come back.
Okay.
Okay. So I would also recommend this approach. Look at the code, try to learn it from yourself, learn it by yourself, and if you have any questions, post it on discourse.
Okay, sir, you can scroll down now. Thank you.
Okay. One block at a time.
So can you scroll up a little bit? The third block from the starting. Yeah. 20. In which we are setting up the mesh grid.
Yeah, this is the one. Is it visible? Mesh grid?
Yes, sir, yes. Yes, sir, yes. Okay, sir. So now you can scroll down.
Okay.
Okay. Thank you.
Yes, Sayed, I would request you to share these screenshots with your fellow learners as well. They might also benefit from it.
Okay, sir. Thank you. And okay, sir. I hope I will share it.
Sir, can you scroll up, sir, so that I can take the screenshot of first block, first visualization.
First visualization. That means
no,
this
sir.
one.
Sir. Yeah. No, sir. Can you scroll down?
This one.
Yes, this one.
Okay. I think one of you should take the screenshots and share with everyone. What do you think?
Okay, sir. I'll do it. Sir, should I post it on discourse?
Yeah, that is fine. Just the screenshots,
Okay,
not the code. Okay.
Yeah. Okay, sir. Okay, sir. So if everyone is taken, so now you can go to the Lasso part.
One. Okay.
Yes, sir.
Should I move down?
Yes, sir.
Click on the right arrow of the corner, sir. That will more code will be visible. Yeah.
Okay, sure.
Blue one. Okay. So thank you, sir. So I've taken the screenshots.
Okay, great.
So thank you very much.
So I have one doubt in this. If you go up on this, where we combine all the charts. If you just go up.
Right. Yeah, give me 1 minute. I'll share my screen.
Also, sir, why Lasso gives a sparse matrix? That
question, right? Okay, so I'll have to refer to this video. Can you please post this question on discourse? I'll come back to you.
Yes, sir.
So, not this.
Is this one?
No, sir. If you can keep going on top, where the visualization is given for all various, training and the predicted. Yeah, this one. Now here, what I'm getting, I don't know why. I'm not getting it in a single block like you got this subplot.
I see.
I'm getting in a straight line.
I'm also getting the same issue.
Yeah, and
it's coming down by down.
And the error is no handles with labels found to put in. I don't know. And
I see. So I see. So you are able to generate the plots, but they are not stacked side by side or
they
on
are
top
not.
of each other.
And I'm getting the last plot is coming empty, and there is it's coming with no handles with labels found to put in legend.
I see.
And the legend is overwriting sometimes.
For me, the first one is empty, and there are no labels like the degree or the lambda.
I see. I see. So, can I request you to do one thing? Create your. You must have used collabs to create these visualizations, right?
Yes, sir. So
Yes, sir.
should I post my code on Discourse?
Sir,
Of
I have
course, of
already
course.
posted it regarding
because-
subplots.
It is because in the videos, the codes or visualization codes which are available are kind of that is half screen. That's why there is some code might be hidden on the other side.
Yes,
That's why
yes.
that's the main reason I thought about.
I see. I see. So I can assure you from the next weeks onward, you will not see this problem. Okay. Somebody was mentioning that.
Could we see the visualization code once, sir? Because if we can
Of
see it fully,
course.
probably we can recreate it. So
There it is.
no, the one which does this visualize model fit. I think that's where the
Okay.
problem is coming.
Okay. I think sir must have defined it.
That function.
There it is.
Okay. Okay, thank you.
Okay, sure. Okay. Now shall we go through the programming questions of week 3?
Yes, sir.
Yes, sir.
Sir, can you recommend any study material or something videos to understand the visualization part, like Matplotlib and Seaborn, so that we can.
Okay. So there are many resources, many books, many YouTube videos available for visualization, but we are touching the surface of visualizations only. So visualization itself is it can become a course because when you come to designing your custom visualizations, you'll have to dig deeper inside a library. But what we want to do is we want to just create the standard charts and standard formats that we want to follow. For example, creating subplots. So, okay, let me give you a few links.
Because there is an abundance of material available, so it's kind of confusing which to trust which one is better or not. That's it.
Right. I understand your point. So, can you please post a discourse post, and I'll reply to that. With I'll collect some materials, review them, and share it with you. Okay.
Yes, sir.
All right. Okay. Is my screen visible?
Yes, sir.
All right. So our first programming question is: consider input feature vector x. The shape of x is fixed 1/3, and the degree of the polynomial is a random number between 2 to 10. Write a function named polynomial transform which takes the feature vector and degree of the polynomial as inputs and return the transformed polynomial feature as output as a numpy array.
This is already given in the lecture.
Yes, that is true. That's true. So how many programming questions we have? I think we have only 2, right? And we have a good 35 minutes. So I would suggest you to try it.
No, sir. I tried, but I was not able to miss. Sir, that input part that we have to take the fixed vector of 1 cross 3. So means I was putting some code for the taking input from the user, but that was not working. While for the in the collab it was working, means, but it is not working.
Okay, you can share your code. You can try it. We can try to debug it.
Okay, sir. Okay, sir. Okay, sir. Just let me copy my code from the that.
Yeah, sure. Okay, so instead of writing the entire code, I'm going to just write the logic behind it. So does that make sense? So will that help everyone?
Yes, sir. First we.
So this code is the same as what is given in the. There's no. I mean, you just have to remove the login part and you get the.
With the logging part.
Yes, you are absolutely right. That's the answer of this question.
Sir, I put my code.
Okay.
But I have hashed something because I tried with this, but it was not working. So
okay,
we have to remove the hashes.
Okay, let's see. Okay. Get combinations. It looks like you just this looks exactly same as what sir has mentioned in the video, right?
Yes, sir. When I was trying in the collab now with the input, I was removed that hash part, and I was X is asking for the input from the user, and I was giving the input. So in the collab it was working. It is working, but in this it is not working. I might be certainly doing some mistakes, but I want to know where I'm making the mistake.
Okay, sure. Let's try this out. So let me remove the logging part altogether. You're not returning. See this one. This return statement should not be inside if.
Okay.
Let me remove entire all the logging part.
With syntax part, I have made the mistake.
Yes.
Let's see.
Sir.
Yes.
Sir, we are defining. Actually, we have to code for a function, so we don't need to mandatorily from our side. We have to put the input to function or something like that, because in the test cases, the values will be given through the function only.
Absolutely right. Yes. So, are we taking over any input from here? Yeah. So input part is commented.
Yes, sir. I commented because it was not taking any kind of input. If I remove the hash, so it will show some kind of error.
Okay, so this part is anyway not necessary. We are not taking input from a user. A system is going to provide the input.
Okay.
So I think this looks okay.
No, sir, that combination, get combination, I think you'll have to put X, because elsewhere you're defining as X. Lambda is X, or you'll have to put L everywhere.
Well, this is a local variable, right? So don't have to worry about it.
Okay, so then we'll have to put the local variable everywhere, the same. Yeah.
No, that's fine. So even when we are calling it on L_T, this L is different from this L. Okay, so this function.
Yeah. Right.
Okay.
Right.
Actually, sir, I was using L for the list. I was giving input X and Y and appending into the list, and this list was my L.
List was L.
I was taking input from the user, na? That's why I used
I see. So let me comment this one now. We don't need it. And why degree is equal to NP? This is also not needed.
Okay.
Degree is a number, right? If you look at the question, degree is a random number between 2 to 10, right? It's a number, not a vector or anything. So you don't have to create an array out of it.
Okay. And this, we don't have to take input from the user.
Absolutely. So we have removed the input statements.
Okay. So
see, all test cases are being passed.
Okay. Thank you, sir. So, Mr. I was fetching difficulty in that input part only. Generally, we take input from the user because 1x3 matrix means numbers can be anything.
Right. Of course, the numbers can be anything. So since this is automatically evaluated program, so you don't have to take inputs from user.
So, sir, can you little bit give some guidance, because I normally make mistake in this one because this is some kind of change from the Python.
I see. So in Python also you had similar setting, right? You had to write a function. It accepts some kind of input. You do the processing inside that function and return the output. The system, the portal or the system, uses some kind of test cases which has the portal already has a corrected set of pairs. Each pair, what should be the input, what should be the output. This kind of pair is provided, and your function is called upon the first set of items inside that. The first item in that pair is passed into your function. It produces the output. Then your standard answer is compared with the output produced by your function, and then it is decided whether you pass your test case or not. It is exactly same as that in Python. Hello.
Yes, oh, yes, sir.
Yeah, so you don't have to worry about it. If you are comfortable with Python paradigm of writing program and passing the test cases, same situation will happen over here.
Okay, sir.
All right.
So,
yes.
So can you use some alternative, for example, like that dot reshape in place of that line x dot none? Yeah, and
and see the output if it is still the same.
Yes.
Sure. Well, first of all, it is for this particular question, that line might never be executed. Can you tell me why?
Yes, sir. Because the shape of that is fixed. It's 1x3, right?
Exactly. So this condition is only true if the data is of single feature and it is of the form one-dimensional NumPy array. Then only this condition is true and this statement is executed. But I can assure you, you can try out some examples manually, write this code and give it a one-dimensional array. You will see that this line will be executed and this code will work exactly same as the one which was written earlier, which is using this none syntax.
So, sir, to try this code manually in the collab, don't we need that input part? We have to directly define.
Of course, you want to need it. Yeah, right. So again, as I mentioned, you have to manually create some random example and then execute it.
Okay, we have to first fix the means that input.
Yes, yes.
Rather than taking variable input, we have to fix it.
Yeah, just so the question was whether this reshape function is going to work as same as
I got it, sir. Means rather than giving means 1 cross 3, if I give input of 1 cross 1, then it will work. Then it will
not 1 cross 1, 3 comma nothing.
3 comma nothing.
One dimensional.
So it will be 3 comma 1 only.
No, it will not be 3 comma 1. That's see, NumPy treats 1D arrays and 2D arrays differently.
Okay.
As they are not exactly one-dimensional factor and two-dimensional matrix right away as we treat in mathematics.
Okay, sir.
Okay.
Sir?
Yes.
Can you show the whole code? What is?
Okay. I think we have gone through this code in detail a few minutes ago, right? Sometime back. In the beginning of this session.
Sir, here is arrow na, right side, right top on the code window. There are 2 arrows. Click on the code. Full code will be shown. Yes.
Okay. This one.
Yes, sir. Yeah. Thank you, sir. Yeah.
All right. All right. Let's go to question number 2. Consider input feature matrix X, label Y and weight W. Thus, Syed, are you saying something?
Oh, sorry, sir. So I didn't notice my mic was on. Sorry, sir.
Okay. Okay. No problem. Question number 2 is consider. Okay, before we move on, any questions so far? Anything? All right. All right. So let's go to question number 2. Consider input feature matrix X, label Y and weight W. The size of X, Y and W are fixed to be 10 by 3, 10 by 1 and 4 by 1. Write a loss function named ridge underscore lasso to compute ridge regression loss. Sorry, ridge underscore loss. This function should return the loss value in it. It accepts matrix X, label vector Y and weight vector W. Note added dummy feature to X. Okay, I think this is a very approachable question for all of you. Please type in your code in the chat box. Okay, Syed and Vivek have posted their answers. Himanshu as well. Okay, Soumya has also written her answer.
Sir, after this problem, can you please give how to approach the grade problem one question? Just a little.
Sorry, can you please repeat your question?
Sir, after this problem, can you please give the how to approach the graded question first graded programming problem?
Okay, we can discuss.
Just a kind of a little bit of approach.
Sure, we can discuss that. So let me use Syed's answer and see how it performs. So Syed, first thing, always remove this after return statement. Any statement will not be executed, so just remove it. So you have created a feature matrix with a dummy feature, computed the error vector, and then computed the loss. I think this should be correct. All right, it passed fantastically. One suggestion is do not use these parentheses everywhere, right? Because sometimes they have a different meaning. Typically, parentheses are used for creating tuples also. So possibly sometimes you can get into trouble and unnecessary errors. So whenever they are not necessary, just remove them like this. The last set of parentheses was not necessary. This parenthesis is also not necessary. Oh, let me.
Okay, sir. Actually, sir, I take that Bodmas rule very seriously. So I am very that Bodmas rule, na?
Okay. What is that rule?
Bodmas rule, bracket of division, multiplication, addition, and subtraction.
Okay. Well, of course, you have to pay attention to what operations are being performed, but see, you can simplify your code like this.
Okay, sir. Thank you, sir.
But sir, brackets.
This you are multiplying. See, Python will take care of whether you are multiplying vectors or constant with vectors. See, so even here you don't have to write even this quantity you don't have to write inside parentheses.
That will be L by 2 instead of 0.5.
Yes, 0.5
Yes,
looks better. Otherwise, it yeah, somebody can read it like L by 2 instead of 1 by 2. Well, that's a very small thing. But yes, this looks better without using any parenthesis.
Sir, it is L by 2 because we have to put the learning
Yes,
rate.
Yes,
oh, I see.
Second.
So, okay.
The first one is 0.5. 0.5, yeah.
Sir, in this case, how do we know Python takes the @ symbol first or the asterisk first with the multiplication of vectors or the normal multiplication?
Well, you don't have to worry about it. As long as whichever direction it goes, left to right, right to left, it is going to give you the same answer. See, worry about whether your expression is correct or not. See, for example, this is a constant, right?
Yeah.
And these two items are vectors.
Yeah.
Right? So, even logically, if you're solving this by hand, if you multiply this constant with this vector first and do this multiplication later, you're going to get the same answer. And similarly, yeah, if you multiply the matrices, these vectors first or matrices first, and then do the constant multiplication, is still you're going to get the same answer.
Okay.
Sir, how did you undo the correction? Did you
Control
or you
Z.
just okay?
Okay. So I think this looks correct. Let's try it out. Yes, all three test cases are passing. Any questions so far? Okay. And I think somebody was asking for grid for
Yes, yes.
Hint on first graded question. Okay. So this is Government of India is taking several steps to ensure that we are well prepared to face challenges and threats posed by COVID-19. With active support of citizens of India, government has been able to mitigate the spread of the virus so far. One of the most important factors in the fight with the virus is to vaccinate maximum people and enable them to take precautions as per the advisories being issued by different ministries. Total 50 months data and total vaccination in each month is given. After initial data exploration, you got to know that given data don't follow linear model. Fantastic. Now you have to define function model error, which will fit the given data or linear regression model with appropriate degree and return an RMSE. Great question. Yes. What was your query?
Sir, how to overall approach this? Do we have to take the code from the linear regression class which we created from scratch because we are using RMSE error and fit? So that should be the
Yes.
approach or how?
Yes. That's the logic behind it. So think about it. What it is asking of you? It is asking of you to fit a model, linear regression model with appropriate degree return RMSE. So what you will have to do is you will have to run. Right. So first you will have to implement linear regression from scratch with polynomial transformation. Okay. And which will fit the given data on linear regression model with appropriate degree and return the RMSE error. So you will have to find, you will also have to think about the logic, how you choose the degree. Once you have RMSE error for multiple degrees, then how do you choose it? You have to implement that logic also in this question.
So one more question.
Yes.
I can ask. Sir, like in this question, it has been mentioned that all those things, and in the second last line, after the initial data exploration, you got to know that the given data don't follow linear model. So when we approach any new problem with the data given, so what kind of approach, as in, yes, we'll know about that. Is it a regression problem classification or something else? But what is the kind of algorithm or what is the steps which we need to take so as to examine that is it a linear regression or polynomial? So first we have to try on linear, then polynomial, then how for a new data if we are given or we'll try on something like that.
Fantastic question. So you don't know whether it is going to follow polynomial.
Yes. We don't have any idea. We have just encountered the data for the first time. So how is the approach going to be in that case?
Yes. So try it with degree 2. Second degree polynomial transformation. Try to fit your model.
In the first time only.
Yeah. When you're seeing the model, you don't know whether it is the relationship is linear or non-linear, right?
Okay. So what if we find that the model is underfitting and then I go on to the polynomial? I use the linear and I see that the model is underfitting, and then I change on the model to polynomial. Will that not be a approach?
Of course, the definition of underfitting is that what is the symptom of underfitting? The training
the
error
validation
is high.
and the test and the training both are giving high errors. So I check the errors.
Absolutely.
And if the errors are high, then I change the model to polynomial and see if the errors go down. And if they go down, then I can probably put in regulation if I want.
Right.
So can the approach be like that? In the first approach, we visualize the overall data and see is it kind of like the scatter plot which we do for in the lectures as well for the sine wave data. So we created artificial data which follows that particular pattern. So in that approach we used, or do we have to take manually the overall errors that like Vivek has mentioned that we have to overall assess the tested error and the training error.
Right. So see, okay, was it Bhupesh or Venu? Bhupesh, were you saying about the first approach?
No, I was not saying.
So I was.
Vivek, okay, right. So Vivek, I totally agree with your approach. Himanshu, think about this. The examples that we saw in the collabs are actually toy examples, and the data was that data had only one feature. Imagine that you have multi-dimensional data set. Then how would you visualize it to determine whether the relationship is linear or non-linear?
Oh yes, got it.
Right?
Yes.
Yeah. So best way to
learning curve
yes.
was mentioned. Yes.
Right. So learning curves are your answer for figuring out underfitting and overfitting.
Okay, got it. A single feature you can use that visualization, but for multiple features we can't visualize. So
right.
Even for data, yes.
Even for 2D data, data with two features, you can create 3D plots. But again, you'll have to do. You have to rely on your intuition and understanding of 3D functions to figure out the best way. Just use the learning curves.
Yes, learning curves. The data will tell what to.
Absolutely.
So
one can produce a bivariate plot, isn't it? Like y versus x1, y versus x2. If you got 10, we can produce 10 bivariate plots. And if most of the plots are linear, I'll fit linear model. If some are quadratic, curvilinear, then that will be a good hint that polynomial of higher degree is required.
Okay, see, when you're dealing with real world data, it's difficult to figure out if there is any kind of relationship directly looking at these graphs, right? So what happens is sometimes combination of these, when you are doing the higher degree polynomial transformation, you are creating features which involve multiple features and different degrees of those features, right? So these transform features can be very, very powerful. Just by looking at the bivariate plots of these features, I don't know. I'm not sure if we can go ahead with polynomial transformation of certain degree.
I think it helps to do the initial analysis, and if you're lucky, you will hit the bullseye. Otherwise, you will have to go back to hit and trial of performing.
Right. You're right. Actually, for some of the, it is possible that sometimes we can get this kind of connection, this relation that the label vector is a polynomial, is a polynomial function or related to a polynomial function of some feature, any one of the features. If that is the case, of course, that gives you an indication that polynomial features transformation is going to give you better results. But it's not always visible, I would say.
So actually, the problem with polynomial is that the interpretability, because in real life cases, you can't have, x squares or things like that. Can't have sales squares or revenue square. So that's the problem.
Yes. Interpretability might pose challenges.
Yeah, that I somehow like the Lasso because it gives you very few features, kind of feature selection, and your interpretability may not be a problem.
Okay.
And many times it's not just a quadratic transformation. Many times in real life, you actually do piecewise linear, right? So you actually divide the domain into multiple splines, and then you convert and then fit a linear model through those splines. That's a more practical approach of doing that.
So how would it fit a piecewise linear model using Lasso or ridge? Well, see, you can imagine this. Any piecewise model, piecewise linear model, it can be subsumed by a more powerful polynomial function, right or wrong?
Yeah, if you can fit one model, yes. But if it is kind of, if it follows S shape, yes, you can do logit or whatever. But sometimes it's not possible to find a proper transform functions. Then many times in real life.
Right. So what I think is any kind of curve, if you any kind of curve that you want to represent with your model, if you have sufficient degree in that function, the model, I think you can create a good function out of it.
Yeah, but generally anything more than 2 is we are kind of going into the overfitting area, because so it's a trade-off.
I would say it depends on the data.
Yeah.
I think once we do some projects, then we will understand it more, like what are the real life problems, and maybe we will appreciate polynomial more in the.
Sir, I wanted to ask about the projects as well, as we don't have any project in MLT or MLP, so and it is necessary to do a project or
Okay, good question. So this was
can you please
about to come.
recommend, sir?
Yeah, this was about to come in a few days, but I can spill the beans. There will be one project for ML practices this term, and from every term onwards. For every term onwards, yes. So
we'll
this term
have
and onwards.
2 months.
ML practices, there will be a course project component.
Okay, so that will be announced after the first course or some.
Within few days, I think.
So we'll have, because that's necessary, because we need to have a practical approach how to implement all these things in a real world.
Yes, Himanshu. Of course. See, ML practice is the course in which, again, we are doing polynomial transformation by hand. We are fitting linear regression from scratch.
Yes.
But when you are focusing on solving a problem, working on a data set, you don't focus on these internal
These
details.
things, yes, sir, yes.
Right?
You'll
use
just the
SQL
library.
library, TensorFlow library, and so on. So that's the objective of ML practices course. You'll solve problems given that you know the techniques, the models. Right. And ML techniques, the focus is on the internal details, how it works, so that when you need, you can tweak the model, change details, and get the desired results if you want to, if the need is.
It's not dependent on, we don't have to depend on the library. We can tweak different things.
Absolutely, yes.
Applying
Yes.
these things according to our needs.
Absolutely, yes. All right. So in ML practices, there will be 2 data sets throughout the course, which we'll be using continuously. One is for regression, one is for a classification. And you'll see that those are real world data sets. You'll have to do data pre-processing, apply different kinds of models, see their accuracies, their performances, measure them, and then choose which model is working the best. So there, if you want to have that kind of experience, ML practice is the course that will give you that.
Thank you.
Okay. Okay. I think that's all from my side. Any questions?
So one question, is it a good idea to take both of them together, ML practices and ML techniques?
See, it depends upon multiple things. Depends upon the time that you can dedicate to these courses. Depends upon your familiarity with programming in Python, as well as NumPy libraries, sklearn library, because it takes a bit of time to getting used to these things.
Right.
Otherwise, what will happen is both of these things will come together, and they take your attention. One more thing is the online proctored exam for both of these courses will happen on the same day.
Right.
In morning, it will be ML techniques, and in evening, it will be ML practices.
Practices, right. Even I have taken both, sir.
Okay. So yeah, so these factors affect your choice.
So yes, the thing that you mentioned, yes, I'm facing that kind of a thing, because both of these are program heavy subjects, so I'm just shifted in that particular the thing which could have been gone a bit gradually if I have taken the subjects one after the other. But now I'm facing it, but it's
Right. They are both, you rightly pointed out, they are both programming heavy subjects.
Yes.
So my recommendation, if you're coming new to this field, taking them one by one can ease your load a bit.
Yes, sir, I only have MLT as of now. So am I missing something out? Not having MLP together with MLT?
No, you're not missing anything out.
Okay, sir, I just want to ask you a last request, sir. Can you go through the first question of the graded assignment and give me some hint on what should I do?
We just talked about it, right?
No, sir, not the programming question.
Okay.
Not the programming question.
Okay. The graded question. Give me one. If a data sample has 5 features, what will be the number of features after applying 4-degree polynomial transformation? Okay. Yeah, okay. Great question. So since you are applying 4-degree polynomial transformation, this question is asking, after the transformation, how many features will you have in the new augmented feature matrix, right?
Yes, sir. So no, actually, sir, I want to ask you, sir. So there's only one example, one n is equals to 1 and it has 5 features, right?
You can imagine one sample or number of samples, because the answer is not going to change. It depends on number of features only.
Yes, sir. Sir, but do we only have to apply the 4th degree, or we have to apply the 1st, the 2nd, the 3rd, and then the 4th degree?
I think the second one, because all of them, yes.
Okay, sir. Okay, thank you, sir. Thank you very much, sir.
Means here n will be the 4 and the means number of features will be 5. So exactly the questions which we were discussing during the interaction, the formula
right,
part.
so degree is equal to 4.
Yeah.
And features is equal to 5. Yes.
Yeah.
Okay.
Okay, sir.
Thank you, sir.
So, sir, I have a question. Like,
sure,
yeah. So when we do the get combination part, we go from degree 0 to degree n, and during that, we take the those from 0 degree to 5 degree, all the elements from degree 0 to degree n.
Degree from degree 1 to degree n.
Degree 1 to degree n. We remove that one, during explaining this polynomial regression, sir started with 1. So we ignore that 1.
Okay.
Basically, that is degree 0 only.
Right.
Yeah.
But there is only one feature of degree 0.
Yes. So we ignore that and we take from 1 to degree, whatever the degree is like, and
right.
all the features. Okay.
Right.
Thank you.
All right. Any further questions? Okay. I think then we can close the session. Thank you, everyone. It was a great session and great interaction. Bye.
Thank you, sir.
Night.
Thank you, sir. Thank you, sir.
Thank you, sir.
Thank you, sir.